Hello, the following movie covers the Widowhood or bereavement database as shown on Moodle. The analysis I'm going to run through will be the analysis, and I will run through the output that you need to report for your first element of your assignment. For the assignment, there is a choice of two databases for the Anova. It's based on real data taken from Bennett, Smith and Hughes in 2005. The original database was much more extensive than the one I have on Moodle, but I just wanted to keep things simple for the analysis. So basically, from the data that we have on Moodle, we're going to ask three research questions. Is there a main effect of gender on symptoms of depression? Is there a main effect of years bereaved on symptoms of depression? And is there a gender by years bereaved interaction on symptoms of depression? Okay, so all the resources that you need as background to this particular study are shown on Moodle. Here we've got the original paper. You have the data and the assignment brief, as I'm going to be going over the next couple of weeks. So this movie is really just to show you how to analyse the data and interpret the output. So let's have a look at the data. So here we have our SPSS database where we have our two independent variables. Here we have gender, which is we're going to explore for one of our main effects, coded as 1 for women, 2 for men. And then we have years bereaved, which was split into a categorical variable, which was recoded from the original data. And we get the median score, which was 7 years, and split it into people who've been bereaved less than 7 years, and then 7 years plus. So here we have our data, and our dependent variable is the HAD depression scores. Okay, so the first thing we're going to do is explore our data. So to do this, we're going to analyse descriptive statistics, explore, and as before, I'm going to split the output by the factors and the levels of those factors. So the first thing I'm going to do is move the factors into the factor list. So that's years bereaved and gender. Our dependent variable is the total depression scores. I'm going to select histogram and normality plots with tests, continue, and OK. So let's explore the output and make some decisions about whether our data are normally distributed or non-normal. So we'll just wait for the output. So here we can see our group sizes, how they split, roughly equal. We'll skim past the descriptive statistics and look at our tests of normality. Now here we can see we potentially have a little bit of a problem. Our data, according to the Kolmogorov-Smirnov test, are non-normal. But let's have a look at the histograms. Now here we can see the shape of the frequency histogram actually looks pretty normal. So 1 out of 2 so far. This is for women, by the way, and the dependent variable is their depression score. So we can see we have what looks like an approximately normal distribution. Let's have a look at the same for men. Well, we could suggest that there might be some evidence of skew, but it's not too extreme. So looking at the histograms, I would probably suggest that we are erring towards normal. Here's our QQ plot for women. Here we can see the line representing expected normal distribution and the dots representing our data, and it kind of tails off here towards the top end. But looking at the histograms, I would say we have potentially a normal distribution. Then finally, excuse me, if we look at the box and whisker plots, we can see we don't have any outliers. For the purpose of this assignment, we do want to proceed with an Anova, so slight deviations from normal are perfectly fine, but you might want to say that there was evidence of some skew, however, it was decided to proceed with the Anova. Let's have a look at the years bereaved scores now, so less than 7 years, 7 years plus. We split the group at 7 years. So if we look at the Kolmogorov-Smirnov test, we can see that we've got for 7 years plus, it looks pretty normal, but the less than 7 years bereaved, we can see again that p-value is less than 0.05, so it's indicating that one out of those two distributions are not normal. So let's have a look at this less than 7 years. Well, again, we can see that we have some positive skew here, but again, we do want to proceed with the Anova, so we can clearly state that the decision was taken to proceed with the Anova. Here we can see the 7 years plus distribution, and that looks pretty normal. The QQ plot, again, the line versus the dots representing our data. Again, there's some deviation from the line there for less than 7 years. 7 years plus, which we were told by the Kolmogorov-Smirnov test was normally distributed, you can see are adhering much closer to the line. So let's complete this by looking at our box and whisker plots, and here we can see again we don't have any outliers. So although that's a bit of a whiz through the normality tests, the final conclusion would be that there was some deviation from normality. However, it was decided that we would proceed with the analysis of variance. Okay, so once we've made that statement, obviously following our statement of our research questions, what we will do is we will deal with each one of those research questions with our analysis of variance. So to do this, we're going to analyse general linear model univariate. Okay. Our dependent variable is the total HAD depression scores, and our fixed factors, our independent variables, are gender and years bereaved. Okay, so now we've entered them into the appropriate boxes, what we need to do is create a plot just in case we have an interaction. We want to look at that graphically. Again, because we only have two levels of each factor, it doesn't really matter which variable goes on which axis. So we add them to the box, to the plots box, continue. Excuse me again. We've no need to carry out post hoc tests because we only have two levels of each factor. And then finally, we go to our options. Now remember, options on the older version covers both estimated marginal means and display. In the newer version, you have to click on estimated marginal means separately. So let's move these across to the display means for. Get them all in there. You can drag them across, by the way, but I'm clicking them across. Compare main effects, because we might want to look at the main differences in those groups. And again, select Bonferroni. And then finally, descriptive statistics for our means and standard deviations, estimates of effect size, and homogeneity tests. Click continue. We've done everything, so we click on OK, and again, wait for our output. So the between subjects factors table just reminds us what our factors are, what our levels are. We don't have to include that table in our output. However, we do have to include a table of means and standard deviations because we might want to refer back to these once we've done our inferential statistics, our ANOVA. So again, we can comment on the means. We can look at these mean scores and unpick them. So women bereaved less than 7 years score 4.58, standard deviation 2.95. We can look and kind of unpick little bits about what's happening with the dependent variable for each of these factors and levels. So include a table of means and comment on the table, but do not discuss significance because our ANOVA, we haven't done our ANOVA yet. So what we will do when we do our ANOVA is go back to the table of means and discuss any significant main effects that are relating to those. Okay, the next table we look at, which we do not include in our output, is our Levene's test of equality of variances. Now again, our homogeneity of variance assumption this time has been violated because our sig or p-value is less than 0.05. But as with the normality, because this is an exercise that we want you to complete an ANOVA with, it's perfectly fine to state that our data did violate the assumption, that our Levene's test indicated that. However, the decision was taken to proceed with the ANOVA. So next we'll move on to the table that has all the information that we need in order to complete our analysis. So the first, one of the questions we had was, is there a main effect of gender? Well, here we look at the horizontal line relating to gender. We look at our sig or p-value and we can see that's non-significant. So we do not have a significant main effect of gender. And in our output, in our write-up, we can report the ANOVA. So F, degrees of freedom, 1,84 equals 0.19, p-value equals 0.66. We've no need to report the partial letter squared because it's so minimal. But it's useful to report P equals because then it demonstrates to the reader just how non-significant that main effect is. So P equals 0.66. The next question was, do we have a main effect or a significant main effect of years bereaved? Here again we can look along the row that relates to years bereaved and we can see that we have a significant main effect of years bereaved. Again, F, degrees of freedom, 1,84 equals 51.45 and P is less than 0.05 and our partial letter squared is telling us that the effect of years bereaved is actually explaining 38% of the variance in depression. And then finally, we look at our interaction. Do we have a gender by years bereaved interaction? Yes, we do. We have a significant interaction here. Again, F, degrees of freedom, 1,84 equals 5.84 and our p-value is less than 0.05. The interaction by gender and years bereaved is explaining 7% of the variance in the dependent variable. So what we can then do when we've reported this, we can refer back to the means and look at our main effects and actually for the significant main effect of years bereaved, if we go back to our table of means, we can see that participants who have been bereaved 7 years plus are scoring significantly higher in depression than participants who have been bereaved less than 7 years. So we can go back to our table of means and say, yes, this difference is significant. Okay, so we've established we have a main effect of years bereaved and a gender by years bereaved interaction. So the next thing to do is to actually look at our profile plots and see where the source of the interaction is. Now here we can see by the line graph that the source of our interaction is at males. So males who have been bereaved longer than 7 years score significantly higher in depression than males who have been bereaved less than 7 years. What seems to be happening for females is the opposite effect. So what we might want to do is to continue our analysis, and I would suggest that you do this, and that is to carry out simple main effects analysis by carrying out a t-test selecting men only, and then running a t-test on years bereaved and with depression scores as your dependent variable. And again, if you wanted to, you could select women only and run the same t-test on the years bereaved comparison, running an independent t-test comparing years bereaved on depression scores for women only, and then years bereaved on depression scores for men only, using the select cases option, which is on the previous video available. So that's how to run the analysis. The order in which you report them should be well structured, so report your main effects first. So is there a main effect of years bereaved? Is there a main effect of gender? And is there a gender by years bereaved interaction?